I think it's gone. Okay. Okay, so first thing, we got the Beta little drone. Is that on my desk still? That's over by the phone. It's a tiny little drone. It's about the size of your hand. But the nice thing about it is that it connects to our real transmitter. So the same transmitter that we'll be using for actual drone flights for the not Mavic Pro, the bigger drone, is going to be, we can basically practice on this little guy. The little guy also has a camera, so that's going to be nice. It's going to make it possible to do some practicing with. It's probably not going to be useful for any surveying, but it does do first-person video. So we'll either get some goggles so that we can fly around, or a screen, or both, to just kind of practice that. Having that first-person video is going to be really useful. The Mavic kind of does that automatically, but the open source stuff is kind of a little extra amount of components that have to go on it. So, but it's really useful. One of the drone crashes I had in Mexico would have been avoidable if we had had first-person video. We just didn't realize we were going to hit that tree. Okay. Yeah, that was kind of an interesting story. We were flying above the canopy and kind of set the flight height based on the kind of tree height around us. But there was like this one tree that was just like enormous, different species, and just kind of poked up into the sky. Oh, wow. And we hit it. So that was too bad. But we would have known that was going to happen if we had had first-person video. So hopefully this will do it. The configuration really wasn't too bad once I kind of got the hang of it again. Ryley and I went through that last week, but ran out of time. So there are really only 3 settings. They're all detailed on this. So I took screen captures of the controller configuration, but the YouTube channel kind of goes through all of them pretty well. So that should get us there for next time. Some good progress with the Lidar and the Oculus. Last week I was having some trouble with viewing the Virginia Tech area. Part of the reason for that was that it was in feet and not meters, and so that was causing this rather severe. It doesn't make any difference except for that what happened was there's an algorithm, or there's a component in the software that basically says if the point is too far away, then don't render it. And so when it was feet, not meters, everything seems like it's 3 times further away. Okay. And so it was clipping things really close. When I had done it with the DeKalb point cloud, it was noticeable and it was doing the clipping, but it wasn't enough that it bothered like the interaction with the cloud. So what I found out is that if you just change the scaling factor and basically just multiply all of the points by 0.01, which is really easy to do in Cloud Compare, you can actually do it right when it imports, then the whole thing shrinks, and then the far plane clipping thinks everything is close, and so it doesn't clip anything. And so I think that you'd have to kind of manage what your graphics card can do versus how many points you have, but it's a super easy fix. I showed you the immersive 2017 stuff, didn't I? Or maybe not. You saw it last week. So is that with the goggles? Yeah, but last week I think we did the 2010 data, so I don't know if you've seen the 2007 data. Okay, no, I'd like to check it out. I saw the Stadium. It's quite a bit better. So it's about 3 times better than the other stuff, and it's all colored. They had a big, they had a nice orthophoto that came with it. So yeah, it actually came out looking pretty good. That was a 3-inch resolution orthophoto, which you don't get every day. I was going to have to use the NAPE imagery, which is what I did for the old stuff, but the new stuff came with an orthophoto, so that was nice. One of the things that I've been putting off for a long time was working on this REU report. So over the summer, I was in Mexico working with Andrea Savadra on a project flying drones and sort of trying to get a good estimate of ground surface height that they want to use for groundwater modeling. I'd kind of been not working on that for a while, working on some other things. And so it was nice to finally get a chance to get back to that. And what I did this week was trying to do a reconstruction of the SRTM validation studies. So when Aster GDEM came out, and particularly GDEM version 2 in 2011, there's this whole spate of studies that sort of describe how good that data is, right? So we think of like the satellite elevation data. It's global, it's awesome, but we don't really worry too much about the accuracy of it, right? It's good enough, right? You download it, you use it, it looks okay. But there have been some studies that have basically compared the heights that you would get from those against the benchmarks around the United States. So there's 18,000 of these professionally surveyed GPS benchmarks. So that's yeah. And so those should be accurate to within a centimeter, right? Probably better. I suppose it varies a little bit, but way more accurate than the SRTM data or the Aster data. The upper right is a map of where those GPS points are. So one thing right away, you notice that it's very uneven. So some states have a lot, and some states don't. Excuse me. I'm a little unsure about just using all of the stations. I think it would probably be better to subsample in Minnesota and Florida and North Carolina, just so that they don't unevenly bias the results. I don't think it's going to make a huge bunch of difference, but I think I'd be more comfortable if that were the case. I'm probably not going to redo it, but just something to keep in mind. The reason that that's important is because what they did was they tied the accuracy results to land cover. So at the bottom, there's a graph that has the root mean squared error for 3 of these different sensors. So GDEM, the National Elevation Data Set, and the SRTM data set. And so the quality varies a lot based on land cover and based on the instrument particularly. So woody wetlands on the left has the highest error rate of close to 10, and that drops to just over 7 by the time you get to cultivated crops. So basically land cover is influencing the quality of the signal. Wow. So the SRTM data is almost twice as good as the GDEM data, which is good to know, because if you're going to use an elevation data set, I probably would have gone to Aster GDEM since it's newer, but this suggests that maybe that's not a good idea and that using SRTM is the way to go, because it's almost half the error of Aster. So that's neat. And then the NED, which has a lot more control on it, is quite a bit better. So the NED data set is about half the error of the SRTM data set. So you really can tell the difference between these. I did the analysis in Arc Pro, which I'll kind of mention here in just a second. I ordinarily probably would have done this in Python, but it's a really big data set. And so Arc had the ability to sort of process through the data offline, but it only does bilinear interpolation. So the interpolator for this is only okay. It could be a lot better. So when we say the accuracy, some of the error associated in this has to do with the interpolation as opposed to the data. The data might be better. You might be able to achieve better results with a better interpolator. So that'd be interesting. I had all the 90-meter SRTM data, so I could run that myself. I wanted to use the 30-meter SRTM data and particularly use it for Mexico. We use this in the JUVIS class a lot, but Derek Watkins put up this really nice web map called the 30-meter SRTM tile downloader. The other one is called Tile Grabber. Have you used this before? Oh, it's fantastic. So if you want to download SRTM data, it's by far the easiest way to do it. You just Google it, it's a little web map. You just pick your tile and like it's on your desktop in 20 seconds. Way faster than going through like USGS's Earth Explorer, which is fine, but this is way faster. So, but the resolution or the tile size is, I think, shoot, is this 1 degree? You can probably tell from the, I think it's 1 degree tiles. It's a pile of data to download. So ordinarily what I would do is just download the little section that I need, but having done that a lot, I'm ready to not do that anymore. So I was just going to download all of the data. And so one of the really great things that he did is if you look at the towards the bottom of that text, It says for manual bulk downloads, a GeoJSON indexing DEM file names lives here. Use this base URL. He didn't have to throw that in there, but that was super nice because that basically lets you bring this in. A GeoJSON is essentially just like another version of a shapefile. So you can get the shapefile, you can open it, you can get the data into Excel, you can make a giant list, and then I could use wget to just download the whole list. So with about 10 minutes of work to get a file list generated, I could just set the computer up to download the stuff, and with just a simple command. So it's just wget this list of files that I made based on those two things, and then it all showed up. Actually, I just looked at that today because I just built the raster mosaic, and it looks like I need to change the base URL for part of it because I only got the center, like equatorial section, like maybe 10 degrees on either side of the equator. So I do need to change something, but that was already like 4,500 files or something like that. Or maybe there was just an error in building the database. I don't know. So as I said, I probably would have done this analysis in Python, but Python, I can't load that many SRTM tiles all at once, and so I don't know. And it doesn't have offline sort of raster mosaic data structures like ARC does. So that kind of is going to make me need to do some processing on disk rather than in memory. So I'm going to need to work with, I talked to some people that I know that do some of this stuff. So Dask seems to be the thing to use here. This is just a tool for interacting with extremely large NumPy arrays that won't fit in memory. Ordinarily what I did is just buy more memory, but I've topped my machine out at 128 gigs, which is great, but still probably not big enough to handle some of that, all of that SRTM data glued together, which I think is like a terabyte or something. Okay, so that's just to set up what the real work is, which is to say that I need to assess how good the SRTM data is for the part of Mexico that I was in. This actually led to another problem. So in the United States, there was a file here, this CONUS reference station's easy to get. It's literally just a web page that lists an Excel file that has all of the XYZ coordinates for all of those benchmarks. So you can download a single file and be off to the races doing your analysis, which was awesome. That was that's been a challenge figuring out where to get that data. So Mexico also has control points, but getting a hold of them has been really hard. There's a web map where you can kind of browse and find one at a time. Molly, actually, if I'd be interested in sending this your way to see if you have any ideas. I wasn't able to figure out a good way to pick up the underlying data from that web map, but maybe you'd have an idea of how to do that. I kept kind of poking through the website. So the government organization in Mexico that handles this is INEGI, the National Institute for, I think the E is statistics and G is geography. I did finally come across this page, this beta.inegi.org.mex, and it does list all of the stations, which is what I've been looking for 5 months. Again, kind of getting through this website. I speak a little bit of Spanish, but it was challenging. I mean, you guys know how hard it is to find data on the United States website sometimes, so yeah, it was fun. Anyway, I did find it. It seems to have these all downloaded by state, essentially. And then the states are divided up into municipalities. My study area, one of the municipalities was carved out of the municipality that Cancun was in. And so even though there are some new markers, they aren't showing up in this data set. So that makes it a little bit challenging because I know, for instance, that the second one here with the ID of 525798, that's like a perfect one because it was in my study area and it was validated in 2017. But because it's part of this new municipality, it's not showing up on this other list. So I'll have to maybe do some figuring out about how to get that stuff, but that's okay. I can do that. So that's it for me. One of my goals for the last 2 months has been work on the REU report, so I'm happy to be having done that. I have not yet flown the Mavic, which I need to do, so that's one of my goals for today. And I've got a request in to fly at 3 p.m. today that has not yet been approved yet. So I don't know if I'm going to be flying on campus today or not, but we'll find out. So next week, I want to keep working on the REU report. It's Thanksgiving, so I'm probably not going to be spending a heck of a lot of time on this stuff, but some. The spatial interpolation, so I kind of said that maybe the SRTM data could yield better results if the spatial interpolator were better. There are better interpolators in Python, but I'm still, this kind of goes back a couple of reports ago, but I'm still got some ideas about how to improve that stuff, kind of based on a natural neighbor sampling, and then get the VT sample. So that's it for me.
Cool.
Yeah.
Yeah, I've just got on this, you mean, or conversation, or?
Yeah. Any questions on any of that?
Sounds like you've been busy.
Yeah.
Well, yeah, I guess so. I'm always trying to get these things are good motivators to try to get stuff done, which I like.
Definitely.
What data did you use for the, is it the Oculus Rift? Virginia Tech's campus?
Peter Sforza had a 2017 scan. So there's the 2010 data that we've been working with in class, but he gave me a 2017 scan, which is not for public release, unfortunately. So
oh, okay.
Licensing associated with it that he said we can't give it out. So I have a copy, but I can't share it. But I can show it to you guys. I just can't give it to you.
Cool.
Very cool. And if Molly, if you were interested in that data, you probably could contact Peter. He may be willing.
Yeah, for sure. I would definitely start there if it's something that you're interested in. It wasn't, the resolution of it was not as good as I was hoping.
Really?
Yeah, at six returns per square meter. It's good, but it's not, what I like to work with is like 100, like that's a good number for me.
So when you say 6 returns, and this might make me sound ignorant, but the laser is hitting within a square meter 6 times?
Yeah.
That's basically what's happening?
Yeah. Okay. There are a couple of different metrics for like return density. So returns per square meter is kind of my favorite because it's like how many landed in this box, like 1, 5, 100. Sometimes they'll also talk about like the average distance between returns. So they might say like, if you have 1 return per square meter, then the average distance between returns is like 1. If you have 2, then it's like a half. So, that's the other way that they tend to do it.
And it probably depends too on how far the sensor is away from the ground, maybe, or how large the laser point is when it hits the ground.
Yeah, that's a big influence. So that how fast you fly is the other thing. So if you're in a helicopter and you go real slow, then you're going to get a lot more points. And if you're in an airplane and you kind of zip by, then you're not going to sample as much.
Makes sense. I don't have a whole lot today. I just figured I'd go over a few of my personal goals.
Can you still see the screen, Molly?
Yeah, I can.
All right. So that's fine. So this week, got a few things done. I was able to establish an unofficial graduate committee. It's exciting. So Dr. Pringle here and Valerie Thomas both agreed to help me with my master's thesis. So we'll work on paperwork for that in the coming weeks.
That's exciting.
Definitely. Thanks again.
Sure. Yeah, of course.
I presented my draft literature review this week and was pretty confident in speaking about it. I have a few things I want to develop further, maybe a little bit more about the biogeographic aspects of the project instead of just solely focusing on the drone work, but it's a balance I'm trying to find. Let's see, also got some good schoolwork done this week. Next week, I plan on finishing up the literature review to present for the research methods course I'm taking. Obviously, I'll still continue to develop it for the purposes of the proposal. I'm hoping to get in paperwork, my plan of study, which also includes the finalization of the graduate committee next week or the following week, and finish up this semester strong.
Very good.
And this week, I went and talked with Valerie Thomas and a bit about Lidar, remote sensing, which is really a topic I'm sort of starting to explore myself. Some of the technical aspects, obviously, I'm unfamiliar with, but it's all very interesting to me. And as a part of the master's thesis project I'm looking to perform, we'll be categorizing land cover based on satellite imagery, maybe some imagery we acquire using unmanned aerial systems. And she mentioned machine learning as one avenue for categorization of land cover. And I thought it was interesting, sort of related to the paper we talked about last week, Kinaway et al. They use the decision tree classification software, which I think is similar, right? Machine learning concept. And so I just wanted to know, kind of facilitate a conversation on this topic and see what you all knew.
Yeah, so machine learning is definitely done. I mean, almost always now for remote sensing classification. There are two resources that I might have for you. One is a person that I met at a conference who was working on a web-based classifier, and the reason she was developing it was for pedagogical purposes. So you, instead of like, doing all your classification in AirDOS Imagine or something like that, you could use this web page and kind of go through and sort of do a classification. And I think she was doing like drought versus non-drought conditions in California, because it was a hot topic a couple of years ago. But it was a neat way to sort of explore the concepts without like getting into the guts of it. So at some point when I get into the guts of it, but in terms of just sort of like familiarizing yourself with the issues, like I thought it was a fantastic interface. So she was out of Germany. We'll talk after the meeting, and I'll see if I can dig up her name.
Awesome, I appreciate that.
The other one is, so I think I mentioned this last time, this was a software called Orange. So Orange can be used for a lot of machine learning problems. So this is it. You can download it. There's probably some tutorials, and I think you might find that this is a good start to just sort of. It's not remote sensing particularly, although I first encountered it with a remote sensing problem. So yeah, you may find this to be useful as well.
Awesome.
So yeah, maybe look into that, and in a week or two, we can.
Yeah, we'll come back and talk about it.
Yeah,
definitely. Cool.
I know in ArcGIS, I don't know if it's in Pro, but I know in ArcMap they do allow you to do classified. Is it unclassified? What is it called?
Supervised classification?
Yes, that's what I'm trying to say. It's either unsupervised or supervised or both, but I know I've done it before in there. So that's a pretty like easy, quick way to do it. They have a lot of good documentation online, which is why I recommend it. If you want to like actually take courses on it, I know through the business IT department, you have to take the Java prerequisite programming course, and then they have big data and machine learning as a class that you can take after that.
Oh, very cool.
Are you taking that next semester, Molly?
Yeah, I'm doing the Java course, so then I can get into like the web scraping courses and then the machine learning courses that they offer.
Cool. Yeah, web scraping is really cool. There's some really, I mean, I did some web scraping 5 years ago, and then one of the students that I had in my Python class showed me a new library that they've got, and it's amazing. Like, because I mean, web pages, the more complicated they get, the harder it's been to scrape them. But some of the new tools sort of like, you can get around that. So yeah, that's cool.
So if you're interested in the class, I know the Java class is offered next semester if you don't already have all your courses picked out. You would have to get a letter from your advisor saying that it would help you with your research. And then they'll be like, you don't have any programming experience. We're really tentative about this. And then you just say like, I will do Java all during winter break to get myself up to speed. Because I think the prerequisite is an intro Java course.
Oh, cool.
But if you end up taking it, let me know, because we can like sit and struggle together. It's online too, which is nice.
Oh, cool.
Yeah.
I'll have to look into that.
How much of that goes on? Because I'm still kind of learning my way around here. But like, how much like does Yang or Jim do anything with supervised classification, or does Valerie Thomas teach a class that you can take, or Randy Wynn? There's got to be some people who.
That's a good question.
That is a good question. I know Jim really likes unsupervised classification, and he does a lot of the remote sensing work. So he's probably done it.
Yeah. Yeah, I would ask around and just sort of pick their brains and see what they say about, where can I, because that's between the four of them, somebody's covering that for sure.
Okay, cool.
Yeah.
Cool. Thanks, guys.
Yeah, no problem.
Molly, did you want to present anything this week?
I don't have a PowerPoint, but I'm still working on. I know I talked to you about it, but I can tell Ryley about it.
Okay.
I'm trying to pull out tree canopies from Lidar data. So what I was originally doing is I was going to do the just symbolize it. So I took land cover classification and found like where trees and trees weren't. And then I realized that the land cover classification that Vegetation has isn't actually that accurate as far as where forests are, even though I think it's like a 3-meter resolution. So I was talking to Bill and he wants something a little more accurate. So we've been taking LiDAR data, converting it to a tin, and then saying like any slope greater than 70 degrees, let's pull that out and then see if that matches with the trees. So far, it looks like it's doing a pretty good job, but we're getting a lot of like miscellaneous polygon triangles in places that we know aren't trees. So we're just trying to figure out how to filter through things that aren't actually trees.
Did you look at any of the LAS tools forest classifiers at all?
Oh, I didn't know those existed.
Oh yeah, they're fantastic.
Oh, they do? Okay, yeah, I'll look at that.
If I don't remember, send me an email this afternoon reminding me to send you one.
Okay.
There's one that my master's thesis student used a couple of years ago, and it was a really clever algorithm design and really easy to implement. So.
Oh, that would be awesome.
Yeah.
I think what we want to do is eventually, we created a view shed of the solar panel field, and I think it came out to like 4 or 5 counties.
Okay.
So we want to download all the data off Vegetation for those counties, and then just write a script and hit run, and then filter it through so we have one big data set of where the trees are and where they aren't.
Right. Cool.
Yeah.
How good is the inherent classification? Because some of that LiDAR data should be tagged with like vegetation. Maybe it's not though. Usually they'll run a ground classifier on the data, but they might not always do like a building classifier or a vegetation. But have you looked in the LiDAR files themselves and seen?
Yeah, I was gonna pull it into Cloud Compare and see if I could see it there, because Pro seems pretty limited in what data it would show and allow you to toggle on and off.
Okay. Cool.
Sweet.
Yeah.
All right. Well, thanks for meeting today. I hope you guys have a nice break.
Yeah, definitely.
And
Yeah, no problem.
no
Me too.
meeting obviously next Friday, but we'll see you the Friday after that.
Okay, neat. I'm hoping next semester, once I start grad school, I'll be able to have like more presentations and talk about more things. So
Yeah, don't feel the need to make anything too formal. As you're working during the week, if there's like a screenshot, something that you're doing that people might be interested in seeing, like that's a good start. So yeah, don't think of these things as very polished. Just whatever you're working on,
sounds good.
just an image to snag. That's great.
Kind of build it as you go.
For sure.
It
Yeah.
makes sense.
Yep.
Cool.
Yep. All right.
All right.
Thank you.
Have a good break. Bye.